Okay, so we have our output here from the two sample t-test or the unpaired t-test. Um, and we do need to get an effect size. So this here will give us our p-value. It'll tell us statistical significance. But remember, one of the most important things we want to do is also look at clinical significance when we're talking about differences, or practical significance. So to do that, let me label first of all these variables. This is variable 1, which means it was the variable I selected first. In this case, I'm just going to call it prison family, something like that. And this is no prison. This was the second. That's a pretty crude name there, but I just want to remind myself which these are talking about. And so those column headers will apply for these first three, for the sample means, the sample variances, and the number of observations. This would be 160 data points in that first category, 2,051 in that second category. And remember, we started with over 6,000 points, but a lot of those got removed because they had missing data on the important variables we needed. So the first thing we might want to take a look at is these average number of days per month of poor health. And so we can see here the people who in their childhood had someone in their family go to prison have on average 12, a little over 12 days a month where they're in poor health. And the average for those who have not had or did not have a family member go to prison was 10.5 for this group. So we do see more in this group. A natural first question is, how much more do we see? How many more days per month on average are these people having this poor health? And so that's just a subtraction. We call that the difference in means. Difference just means subtraction. So I'm going to take an equal sign, this one minus this one. It's possible that could be a negative number in your case if this particular sample was higher, and you would just interpret that negative as this group having the higher average by however many that is. In this case, it looks like about 1.5 days per month on average higher. Now, we need a sense of, is that clinically significant? I mean, how big is that relative to the study we're conducting here? So we do this thing called this pooled standard deviation. What we're really doing is we're trying to standardize and find out, is 1.5, is that difference a lot or isn't it? We're trying to get a gauge on how big that difference actually is. So we're going to do some funky math here. However, you can just copy it exactly. So what we need is a weighted average. Basically, we're taking an average of these two numbers, but we know that there's a lot more people in our sample who are part of this group, and so we want to give this particular variance more weight in our average. And that's easy enough to do in this formula. We just select the two things we want to take the average of, and then we drag and select the two things that we use for their weights. And that would give us a weighted average of 113, which notice is much closer to the 112 than it is to the 118. And this isn't quite enough yet. This is just the weighted average. We also need to take the square root. So I'm doing SQRT. Notice I have two sets of parentheses. One is doing the square root, and one is just that weighted average. So look closely at where those parentheses are. And when I have that, I press enter. And this is called the pooled standard deviation. Hedges G is a measure of effect size, of practical or clinical significance. And to calculate it, we take the difference in means and we standardize it. We divide by the pooled standard deviation. So that's a division, and that gives us 0.15, 0.14468, about 0.15. A general rule of thumb, very general rule of thumb, is that 0.2 is a small effect size, 0.5 is a medium, and zero point 0.8 is a large. So we're looking here at a very small practical effect size. In terms of statistical significance, we want to be looking at the p-value, and how do we know which p-value to look at? As it turns out, this is going to be a pretty crucial choice in this situation, right? Because we have below 0.05 here, this would give us statistical significance, whereas this one would not. So which one do we go with? Well, it depends what our research question is. If we ask, is there a difference between between people who had a family member go to prison when they were a child and those who didn't, in terms of average days of poor health per month? Is there a difference? If we're just asking, is there a difference, but we're not asking in which direction, perhaps the ones whose family members went to prison developed some resilience and got stronger. So maybe they even have fewer days of poor health, or maybe vice versa. All the stress wore on them and deteriorated their health, so they have more days of poor health. If we're asking that open-ended question, then we really need to go with a two-tailed p-value. On the other hand, if we're asking a one-tailed question, which would be something like, do people whose family member went to prison when they were a child experience more days of poor health per month than those who don't, that more than, that directional word, instead of just is there a difference without giving an indication of which direction we're going in, that would be a one-tailed test. And here you start to see the difference, this thing called p-hacking or p-torture that Moltulsky was talking about. A researcher who isn't very perhaps moral or who just really wants to see their study succeed might choose this one-tailed p-value, even though their research question was originally this. They may alter their research question to be a one-tailed question, and then say, hey, we found statistical significance. The general rule of thumb is, unless you have very strong reason to believe that there's only one direction this would go, or you really only care about one direction, you should typically do the two-tailed research question. And so that's what I'm going to highlight here. And so if we are looking at this as a two-tailed question, then our p-value is 0.08, which is above that threshold of statistical significance of 0.05. Remember, the lower the p-value, the more evidence against the null hypothesis. In this case, we do not have sufficient evidence against the null hypothesis. We fail to reject the null. In other words, we don't have sufficient evidence that there's any difference in terms of average number of days of happiness between people whose family member, who had a family member go to prison when they were a child, and those who didn't. And you might say, wait, but I do see a difference there. Keep in mind, this is the sample. So Pennsylvania has millions of people in it, right? The people who had answered this survey, we only have 6,000 people. So even though the 6,000 people in our survey, and of ones who answered these questions, we only have about 2,100. So yeah, it's true that among these 2,100, there were more days on average of of poor health for this group. However, it's not strong enough of a difference to say that this is true in general throughout the state of Pennsylvania, much less the United States. So this right here is the key to jumping from what we see going on in the sample and whether or not we believe that is happening in the population. So we did get some evidence in that direction, but not enough to convince us that this difference is going on in the population as well. And also, even if it is going on, this effect size is so small that we really don't see too much of a difference overall, which is, in some sense, I would say a happy message that that children are apparently resilient enough, at least in a physical perspective. We could also examine this in an emotional perspective. But in a physical perspective, there's not enough evidence that there is this difference in average days of poor health per month between the two groups.